right, let's get started. So homework 5 is released. This is, find my mouse. This is on the website right here, homework 5. And we're going to start homework 5 content today. Homework 5, let me just go through the objectives quick. We're building authentication, so we want users to be able to log in securely to our site. So to start off, we have to learn what cookies are. That's today's lecture. So objective 1 doesn't have anything to do with auth necessarily, but this is going to be a mechanic that you're going to use as you set up authentication. So a first visit cookie, we want the page to display one message when a user visits your page, your home page, and another message when they revisit your page, when they leave and come back. So the first time a user visits your page, you're going to display something like welcome. And as always, you can change these messages if you want to personalize your app and make it more interesting. I just have basic ones here. If you just want to get through the assignment, just use my basic generic ones. Display some message. Here I'm just saying welcome. Welcome user, welcome to my wonderful page. And I'm going to set a cookie. You're going to set a cookie when that user visits your page. And then whenever they revisit, if they refresh the page, you're going to check for that cookie. If the cookie exists and it's set, then you're going to display a different message. Here I'm just saying welcome back to signify that, hey, I recognize that you have been here before, and I'm saying something different to you. To test, go to the page, hit refresh, and make sure the message changes. And the TAs might look through the browser console if something's suspicious especially, and make sure that you've done that with cookies. But it'd be pretty difficult to do that without cookies, unless you're completely cheesing it. Objective 2 and 3. Objective, this should be objectives, right? So authentication, it's a huge objective, but it's hard to break down into pieces. Last year I did registration and then authentication as two separate pieces, but it's really hard to test that. Because once you have authentication done, there's no features that are enabled on your site. If users can create accounts, how do we test that if the account was successfully created? There's no good way to test that. So I combined them and said this is both objectives 2 and 3, so this objective has double points. Effectively, authentication is both objectives 2 and 3, but you get the same score for objectives 2 and 3 for this assignment. So this is a double one. This is the bulk of the homework. Of course, point-wise, it's half of the homework. And this is where we're going to allow, I almost said students, users, to register and log in to our page. We're going to build authentication here. This is the big one. This is homework 5, the crux of homework 5. So for this, you'll want a registration form and a login form, each of which takes a username and a password. And by the way, I didn't add it to the assignment, but if you want your registration form to take 2 passwords, which is the common standard, you have to type your password twice and then make sure that they match. If you want to do that, that's fine, but I'm not going to require that. And you have a lot of flexibility in these forms. I didn't give you any HTML for these because you have a lot of choices to make here. We've seen a lot of different ways for a user to send information to the server. You can use HTML forms like we saw the first time we saw them. You can either use URL encoding, you can use multi-part encodings, which you already have the code for multi-part parsing, so that might be a good option. Or you can bypass the form and use JavaScript like we did with the chat app in the last homework. You can read the values from the fields using JavaScript and then send an AJAX request to do this. And then I almost added WebSockets here, but WebSockets don't quite work for login, but you could register with WebSockets and then log in with AJAX if you want. Anyway, you have a lot of flexibility. I don't even know which one to recommend because it's really up to your preferences. Multi-part encoding, for example, is probably the most difficult one, but if you already have the code working from your previous homeworks, that's probably the easiest one if you already have the code set up. If you want to use JSON, parsing with JavaScript and sending an AJAX request is probably the way to go. But if you haven't done AJAX requests before, I mean, I don't think it takes too long to learn, but I only briefly covered it in lecture and I haven't asked you to do one. Anyway, you have a lot of options in how you set up these forms, but 2 forms, each that take username and password, and send that information to the server in some way. Up to you. And I don't even know Well, I already said it, but I don't even know which one would be the easiest one. If you have multi-part encoding code already working, I almost recommended this one, but if you didn't get that working on the previous assignment, if it's not working perfectly, or it only works for specific situations, then that's probably not the way to go. Maybe JavaScript with Ajax is probably the easiest way, and then send JSON objects to the backend. Oh yeah, you did do Ajax in 1.15. Yeah, so if you remember how to do that, and it's not hard, it's easy to look up, or just look at my slides and cut and paste the how to do an Ajax request. You can do it that way. And when the user registers, store a salted hash of their password in your database, and along with their username. This has to be a salted hash of their password. You do have to handle passwords responsibly. For this, I am allowing a library. I recommend using bcrypt for this to do the salting and the hashing, generate random salts, and then hash the passwords. And those are all topics we'll talk about Friday. And we have plenty of time for demos next week. I can demo the library in probably a few different languages and show you how that all works. But there is a security thing. The TAs will be looking at this when they grade. If you're not storing passwords with both, if you're not storing salted hashes only of the passwords, then it's a 0 on half of the assignment because it's a 0 on this objective. And then when the user logs in, take their username, look up their salt and hash, apply the salt to the password they provided, hash it, and then check if the hash matches what you have stored in the database. If it does, display somewhere on your page some message confirming that they are logged in. We don't have any features that are going to be enabled once they are logged in. But mention that they're logged in. Just let them know, hey, you successfully logged in. Or if the authentication failed, let them know, hey, the login failed. So we're keeping it simple, keeping it focused on the authentication side of this. But you want to verify, is this username and password combination valid or is it not? Your server is going to make that decision and then send a message to the user and display that on the page. If it's a page reload, that's fine if this is all it says. If you're using Ajax, you can have this displayed at the top of the page depending on the response from the Ajax request. So a bit of open-endedness on this and how you actually integrate it into your sites, into your app. And then we're going to try it with correct password, incorrect password. We're going to restart, which I looked into it. The Docker Compose up that I added to the previous doc actually doesn't restart the server, as it turns out. So I did replace that with Docker Compose restart, which does exactly what we want. It doesn't wipe the database, but it does wipe all your data structures. So if you're using data structures to store these usernames and passwords, the restart's gonna make sure that you're not doing that. So Docker Compose restart to make sure that you're using a database. And if anything's suspicious or if the TAs are looking through your code, verifying that you are actually using the database from Docker Compose and not using like a CSV file or something. We don't use CSV files. You're too far along in your computer science career to be using text files to store your persistent data. You gotta get away from that. And then objective 4, using authentication tokens. So this is just a one-shot login, and it says you logged in or you failed, but nothing happens after that. Like you're not actually logged in, you just were authenticated. So the last one, authentication tokens, is once a user logs in using your form from objective 2.3, set a cookie, and this is where cookies finally come back. Set a cookie with a token that marks that user as authenticated. And then whenever you see that token, whenever you see a token, one of your tokens, look that token up in your database. You should store that token along with the username. Look that token up in your database. Find the user who's logged in and say, if they have this token, then they must be logged in as this user because I gave that token to the person who successfully authenticated with that username. Look that up in your database and send them a quick message. display a message somewhere in there on the page that says you're logged in as whatever their username is. And it's important that you do display their actual username as a proof of concept that you are treating this user as that specific user on your app. And from there, we could build features on top of that to say, okay, you're this user. I looked up your friends list. Here are your friends. Do you want to DM any of them? Do you want to start a lobby with any of them, etc.? Depending on what app you would want to build on top of this. So for your project, you would build this same functionality, probably with a lot more libraries than we're using here. And then once you have their username associated with a request, you can start building all those features. And for the bonus, adding password requirements to this. There are no password requirements. If your password is just 2 earlier in the assignment, that's fine. For the bonus objective, add password requirements and verify them on the server. Did I mention that actually? A variety. I need to say on the server in here somewhere. This must be made on your server. Front-end checks don't do anything because the user can bypass them all. These checks. And at a minimum, you should have the usual ones and at least one criteria of your choosing in addition to those. And whatever you choose for your criteria, all of the criteria must be clearly displayed on your app. So users know what their password requirements have to be. And that's it. All the grading is the same. I think that's all I need to say about this. Oh, what happened here? Is that just an empty box? I just never used that. Do we have to handle sending the password to the server as basically plain text bytes? So the password can be sent to the server in plain text. In fact, so by the way, this is one of my favorite topics, security, authentication, and the like. And to get you to the point where you can do this homework just isn't going to take me that many slides. It's about 3 days of slides. So if you have questions, if you want to get me sidetracked, these are the 2 weeks to do it. And I'm tempted to get sidetracked on this one. Do you have to send the password as plain text? I might save that for Friday when we're actually talking about that topic, though. But why is this? Did I enter full screen here? Get me out of here. I'm stuck. I'm stuck at this document. No. That's ridiculous. I'll just have to put my slides on top of it. Yeah, I'll just have to put my slides on top of it. So I can't do that demo anyway. Because I don't know how computers work. Oh, boy. All right, let's talk about cookies. But yeah, you should send the password as plain text bytes. So you could I'll do the demo on Friday that I was just thinking of. But go to any site where you authenticate, any site where you log in, open your browser console, go to that network tab, type in your username and password, any 2 strings really. Click submit, and then look at the HTTP request that was generated for your login. I will bet you right now that your password is in plain text in that HTTP request. Your password will be in plain text. I've only found one, half a site where that wasn't the case. It was the mobile version of a site, but their desktop version sent it plain text. But if you shrunk the screen small enough that it would switch to the mobile version and hit refresh, then it would send, I think, an MD5 hash of the password. But just about every single site I've checked is going to send your password in plain text for network traffic. And we can talk at length. I'd love to talk at length, and I do plan on doing it later in the semester in these upcoming weeks, upcoming lectures, as to why that's the case. Why not hash those passwords? Go to school for computer science and get bullied by a computer. Isn't that how we all feel, though? Especially fighting against the compilers and just work. We know deep down that it's our fault, but man, it's frustrating sometimes. So all somebody needs to do is listen to IP to hack an account. No, that's the. So of course not, because that would be insane. We would be extremely vulnerable out there. What we rely on is the fact that that's HTTPS, so it's encrypted when it leaves our machine, and nobody can read that encryption. But that's the only layer of security protecting your password on the internet. Thankfully, it's a very strong layer of security, and it's sufficient, but there's no hashing as your password's flying through the air over Wi-Fi. The hashing only happens on the server side when it's being stored in a database. That's the only time where hashing comes into play, hashing and salting. Nice story. So let's talk about some content. HTTP is stateless. This is something that I've said earlier in the semester. You probably hear it each time you hear about HTTP. At least every time I introduce HTTP in a class, I say HTTP is stateless. What this means is that every time you're getting an HTTP request, you're handling it in complete isolation. You're reading the request itself and then handling the request based on that information. You don't get any other information from the client. You don't check anything else. You check, is this a get or post request for our purposes, or a head or a put, delete, whatever else you want to check. For our purposes, is this a get or post? What's the path? What are the headers? And what's the body of this request? And based on that information and that information alone, you're handling that request. So there's no sense of persistent state. You don't say, okay, I got this request. Oh, and it's from the same person who just sent me that other request. We're not doing any of that. You've never written code like that for any of your homework assignments, for your project or anything. You're never doing that in HTTP because HTTP is stateless. HTTP doesn't give us any more information outside of the request. So this is very restricting, and this isn't, with HTTP alone, that's not really what we want. For example, of course, what we're leading up to these 2 weeks is we want authentication, and we want users to be able to log in to a site and then have all their subsequent requests be associated with that user. We want to be able to say, oh, this request, oh yeah, that's that user who submitted a correct username and password earlier. I'm not going to ask them for their username and password again. I'm just going to say, okay, you're good, because you already authenticated, and then handle that request as that user. So we need more information. We actually need this idea of state to be able to make the internet work the way we want it to. But we can't do that with HTTP alone. HTTP isn't going to say, hey, this user's authenticated. This is the same user before. So we have to add something to HTTP within the confines of HTTP to be able to get this idea of state. So we can just read the request type, the path, and the headers and the body. Somewhere in there, we need to get all the information we need to be able to tell that this is an authenticated user. That's what we need to do. Then we can make a database lookup. After we get the request, we can have state on the server side, which will be critical for that. We can have state on the server side, which is going to help us know, okay, this is an authenticated user, and here's their username. But we can't get any state from HTTP, the protocol itself. So we do have to have state on the server. That's going to be the key. And of course, the answer, I'm sure you've seen this coming a mile away. The answer is cookies here. You've heard about them plenty of times. You've used them if you took 199 with, actually, I think every semester of 199, Alan Hunt had you using cookies. Cookies are going to be used to remember information about a user. And the way cookies work is through HTTP headers. So cookies function I'm a little hesitant to say this, purely, in a sense, there's some nuance there, but purely through HTTP headers. That's how cookies are working within the confines of HTTP. It's in the headers. So headers, cookies live in the HTTP headers. So what we want to do to set cookies, so we want to set a cookie and have that cookie store information about the user. So when we get a request, what we can do is use a specific header to set a cookie, send that back to the client in our response. That client, or specifically that client's browser, is going to read that header and say, oh, there's a cookie that we need to set. It's going to set that cookie and remember it. And then every time that browser makes another request to your server, it's going to send that cookie in a header. Since cookies are working through HTTP headers, and we know something about HTTP headers, they're ASCII only. Cookies are ASCII only. You can't have any other characters in a cookie. They have to be ASCII only characters in cookies because they work through headers. And we know that we can only parse headers using ASCII. We can't have certainly no non-text bytes in there, because now we're decoding the bytes of an image. We're having that issue. So these have to be ASCII. The protocol says you can't even use non-ASCII characters in UTF-8, just to make sure that you're compatible with every server and every browser, ASCII only. So ASCII only cookies. We can't have any other characters in our cookies. So the two headers that we're going to work with are setCookie and cookie. SetCookie is what we use to tell the browser, or tell the client in general, to set a cookie. I don't have anything to add except the name, but that's what we use to set cookies. And cookie is going to contain all the cookies. Despite this being singular, this is going to contain all of the cookies that have been set for this particular user. So let's take a look at the syntax here. SetCookie is going to have a key value pair. Why are they called cookies? That is a good question. I never thought about that. Why are they called cookies? Does anyone know? SetCookie, let's talk about the syntax. These are going to be key value pairs because they leave crumbs. I'll buy it. I'll take that. Separated by an equal sign. So an example, SetCookie, if I want to set a cookie named ID and I want to set it to this value, there's my syntax. In the response, I set this header and I say send that off to the client in my HTTP response. And then next time I get a request from that same user, I expect them to have a header named cookie with an ID equal that. I expect to see that cookie in the subsequent requests. You can only set one cookie at a time with setCookie. You cannot set multiple cookies with a single setCookie. However, you can have multiple headers with the same name. You can have multiple headers with setCookies, so you can have multiple setCookie headers in your response to set multiple cookies. But you can't use one setCookie header and set multiple cookies. By the way, the drinking game today is cookies. If every time I say cookie. Though it's pretty rough at 10:45 a.m. Oh, like fortune cookie with an embedded message? I like that too. So if we want to, we can add more information. Oops. My brain was skipping a few slides. The cookie that we receive, whenever we receive a request with cookies, the cookie header is going to be present. And this will have all the key value pair cookies separated by semicolons. This will have, or can have rather, multiple cookies. So in your parsing, you can see the format here. You want to separate, hopefully by now you have code that parses headers. You're going to get your header named cookie with a value. You're going to split that on semicolons to get each key value pair, and then split each one of those on equal signs. Look for those equal signs to get the key value pairs for each cookie. And then store those in a key value pair data structure, and you'll be on your way to reading cookies. Hopefully there's no issues there. You've done way more difficult parsing so far in this class. That should be pretty much a break to just parse a line like this in this format. I hope you all agree with that. There's no images embedded in there. There's no working with bytes. You can work with strings purely because it has to be all ASCII. So we can parse these cookies and get all of the cookies. And for your homework, you will have multiple cookies. You'll have that first visit cookie and the authentication token. So you have to parse multiple cookies by design. The clients can also set cookies. This is what you did in 199 when you messed around with cookies. You actually use JavaScript in the browser to set a cookie. So the browser can set cookies and the server can set cookies. The server has to set them through the set cookie header. In the browser, you can use some JavaScript to set cookies, or you can open your browser console, look at all your cookies, and modify those cookies. A user can change their cookies at their leisure. There's no security here. The user can alter their cookies, they can add cookies, they can delete cookies, they can do whatever they want with their cookies. So you have to validate these cookies when you receive them. You can't trust the user. Never, ever, ever trust your user. I feel like I don't emphasize that enough, but never, ever, ever trust your user. You cannot trust your users. Do not ever, ever, ever trust your users. They can change their cookies. They can do whatever they want with these. So, for example, a terrible thing to put in a cookie would be their level of access. If you say, this is a regular user, and you store that in a cookie, and then whenever you get a request, say, oh, this is a regular user. Well, somebody can go in there and change regular user to admin and have more access. You can't allow them to do that. They can change their cookies. There's no security. You have to assume cookies can be altered completely. You did that in 365? Good. Yeah, that's a good demonstration to change those cookies and show there's no security here at all. We do have protections against people stealing your cookies, but anybody with access to your device and access to your browser can do whatever the hell they want with your cookies, including you yourself. You can change your cookies. You can delete them. You can disable cookies. You can do whatever you want with your cookies. They're your cookies. Who's going to tell you not to? And you can access those cookies with document.cookie. If you go into your browser on any page that uses cookies, which is like literally every page out there, except mine. I don't use cookies on course websites and really most of the things I use that I develop. I try to avoid cookies. But if any site that uses cookies, go into your browser console, type document.cookie, and it'll show you and all the cookies that are not marked as HTTP only, which is something we're about to talk about. So we're going to eventually use cookies. It'll be next Monday will be the lecture. We're going to use cookies to remember that a user is authenticated. When they authenticate, we set the authentication token as a cookie. And then when that user returns, we say, oh, you have that token, so you must be authenticated as this user because I have this token stored in my database associated with your username. You must be this person. There's no username and password. Well, the username is present there, but not in the cookie, not in the token, in the authentication token. There's no password at all associated with it. So if an attacker is able to hijack one of these authentication cookies, they can be you. They can log in as you without even needing your password. They don't need your password at all if they have your auth token. They don't need your password. They just are you at that point. Why do sites accept all cookies? There's a law in Europe that forces them to do that. That has that pop-up that says, this site uses cookies. Are you sure you want to proceed? There's an EU law that's, politicians are frightened of cookies, even though literally every page, I shouldn't say literally because there are exceptions, but just about every page on the internet. I mean, the internet works on cookies. Any site that has you log in uses cookies. Like, that's how they keep you logged in, is through an authentication token, which is stored in a cookie. So you should assume that if you're on the internet, there are cookies everywhere. But the EU politicians decided, you know what? Let's warn people about that these sites are using cookies, and forced every site, unless they want some hefty fines, they have to have those pop-ups. And it's easier to just have them everywhere than geo-restrict them just to Europe and hope that nobody bypasses that and gets causes a fine. So if somebody steals your cookies, they're you. Like your roommate who has access to your laptop, they don't need to steal your passwords. They don't need to install a keylogger or anything. They just go to your browser, grab your cookies. That's it. Don't hack people unless they deserve it. But if you have access to someone's laptop, you have all their cookies, you can authenticate as them. Yeah, people talking about things they don't understand, and politicians are excellent at that. Like, they're the pinnacle of talking about things they don't understand. To be fair, they would have to understand like everything about everything, which is an impossible task. But why pretend? Why to pretend to understand things? I thought politicians were supposed to consult the experts and listen to their opinion. I feel like they're just doing their own thing. But let's not get political. And it's all sides. I'm not singling out anybody. It's all sides. All politicians behave that way, from what I can tell. So we can also add more information to cookies called directives, which come after the cookie. If we have any directives, we're going to use a semicolon after we set the cookie, and then have our directives after that. We can have multiple directives. If we have multiple directives, separate them by semicolons. So let's talk about what these directives are. First directive, expires. I'm just going to go through these one by one, by the way. This is the rest of the lecture is talking about what these cookie directives are. We already talked about the mechanics of cookies. You set cookie to set one, and then you expect the cookie header to be able to contain the cookies that were set. Expires is an exact moment in time, down to the second, when that cookie should expire, and it has to be in this format. And did I hit my timing? Oh, I'm off by 11 minutes. So this cookie would have expired 11 minutes ago, because I talked about the homework. I didn't factor that in. This cookie expired 11 minutes ago, based on the time that it was in Greenwich at the is it at the prime meridian, right? At the +0 for time zone. This would be 11 minutes ago exactly for today. So in this exact format, specify an exact time when this cookie should expire. Alternative, and once the cookie expires, it's no longer sent. Like, the browser is gonna possibly delete it, but at the very least, it's going to not send it in any subsequent requests anymore after the expiration date. So on the server, after the expiration date, you're never going to see that cookie in a request again, as long as the browser is behaving the way it's supposed to behave, which is a big thing. Like, a lot of the security in the web is based on the browser doing what it's supposed to do, which most modern browsers are going to do the things that they're supposed to do. But an attacker doesn't have to use a modern browser or a mainstream browser. They can write their own browser and use that, which doesn't have any protections. So it's something to keep in mind. But as long as your users that you're trying to protect are using a modern browser, you'll have all these protections. Max age, alternatively, if you don't want to specify an exact moment in time, you can set max age, which is the number of seconds that the cookie will expire after it's been set. So this cookie is going to last for 1 hour after it's been set. If you go to the CSE 199 website, you would set your recitation. You set your recitation section. It would ask you once and then set a cookie to remember that. And that cookie's set to expire 1 year after it's set using max age. So 1 year after you choose your recitation, that cookie expires. So presumably if somebody fails 199 and has to retake the course, we want them to just naturally enter their new recitation section the next time that they retake it. So one use of max age there. If you don't use either expires or max age, the cookie is going to be a session cookie, and it's going to persist until the browser is closed. For your homework, it's okay if you use session cookies. I'll be okay with that. But if you want to get into this a little more, set either expires or max age. So when the user restarts their browser, that cookie is still going to be set. Secure. Set this directive, and that cookie will only be sent over an HTTPS connection. Of course, you can't use this in your assignment because we're using HTTP for the homework, and the cookie would never be set. So if you use secure in your assignment, you'll never see that cookie. The browser will never send that cookie back to you. It won't even set that cookie. It shouldn't set the cookie because it was set. The set cookie itself was sent over an HTTP connection. So the browser should just reject it outright. If you don't want users sniffing out your cookies over an HTTP connection, set the secure and then make sure that it's never sent over those connections. These days, the internet is pretty much exclusively HTTPS, so this is outliving its usefulness to an extent, but it's always nice to have that extra protection and make sure that's not sent over an HTTP connection. HTTP only is something that does help us a lot. This means that the cookie cannot be read using JavaScript. So if somebody uses this document.cookie to read all of your cookies, they're not getting any of the HTTP only cookies. So even if an attacker does inject some JavaScript into your site and gets JavaScript running on your client's machines, they still won't be able to get the HTTP only cookies. This is a very powerful, very important directive to set. The HTTP only, and I didn't specify anything in the homework assignment. I'm realizing a little too late here. I didn't require any directives, but feel free to use them if you want to get practice with these. But HTTP only, you can't read them through JavaScript, so even an attacker injecting JavaScript into your site, if you're somehow vulnerable to JavaScript injection, they still can't read these cookies. You can't read them with JavaScript. The legitimate user can still read them, or anyone with access to their machine can still read and change these cookies in the browser console, but they can't use JavaScript to read them. And that's just HTTP only with capital H, capital O. Path specifies a specific path that must match for this cookie to be sent. So if I set a path of /posts, this cookie is only sent on requests where the path begins with /posts. So if you have cookies that are specific to a certain path on your browser or on your server, you can set the path to have those cookies only sent to that path, so the cookies aren't being sent on every single request as users navigate your entire app. And same site. Same site has 3 separate settings, and these are going to control how your cookies are sent on third-party requests. So, for example, if you embed an image on your, so let me throw out a scenario for you. You write a website, you're proud of it, you're happy with it, and on your website you embed an image that's hosted by Facebook, for example. So you do an HTML element, IMG, and then for the source of the image, you just paste https://facebook.com/images/whatever the URL is. And then that image shows on your page. That request might contain some Facebook cookies, and your site might be handling those Facebook cookies. So if Facebook cookies are being sent on that request, which, by the way, that's what we call a third-party request. We have one domain making a request for content on another domain. So your domain, your server, is making a request to the domain of facebook.com. In this example, that's a third-party request. Same site is going to determine whether or not to send a specific cookie on that request. And there are 3 different settings for this. Lax is only going to send the cookies when navigating to your page. So, for example, that image would not contain the cookie, a lax cookie from facebook.com. But if you had a link on your page that said, click here to go to Facebook, and somebody clicks that link and navigates to facebook.com, then that cookie is going to be sent on that request. This is the default if you don't set any same site. This is the modern default. That wasn't always the case before increasing security concerns. This has become the standard. This is the default that browsers are going to do. If there's no same site set, then they're going to use lax and only send third-party cookies on third-party requests if they're navigating to your site. How easy was it to inject JavaScript into MySpace HTML fields? I don't know. I'm not aware of that attack. If JavaScript can be injected, it's usually pretty easy though, from what I can tell, from what I've seen. The other two, strict, doesn't send cookies on third-party requests at all, even if they're navigating to your page. Cookies are only sent if the request originated at the domain of that cookie. And finally, none cookies are sent on every single request, regardless of anything. These cookies are just sent all over the place. If to tell the browser to use none, the browser is also going to expect you to use the secure directive. Oh, I should have added it right here. This should be same site none, semicolon secure. You have to have the secure directive. Browsers will not allow you to use same site none if you're not using the secure directive. They're only going to send same site none cookies over secure connections, HTTPS connections. And that's it. We have time to demo a little bit. So let me try to escape my own browser here. Silly problem to have. Exit full screen. I don't know. I need a site to go to. How about? Man, look at all these ads. What the hell? Let's go to. Since we talked about it. So here we're at this CC 199. I'm going to choose my recitation because this is the first time that I visited. I'm going to set it. And when I refresh the page, I'm always going to be recitation C3. And it's going to tell me, hey, you're recitation C3. And when I look at the requests that I make, I have my cookie header here, which is going to have all the cookies that are set, including section name. Section group ID, which is derived from that name, and then a bunch of headers that are set probably at the UB level. If I go to application cookies, I can see more information about all these cookies. Domain. Yeah, so these two are from CSE, buffalo.edu. The other ones are from buffalo.edu. These are cookies that are sent on every buffalo.edu request. And none of them are HTTP only or secure. So that means when I go to my console and I do document.cookie, I'm going to see all of those cookies. I can go to these cookies if I want to change my recitation to like Z1000. I'm well within my right to make that change. Now that's a recitation that doesn't exist, of course. And when I go to the page, it will say recitation Z1000, but this site has good fault tolerance. It's still going to serve up content. I believe it treats me as A1 in this case, but the page doesn't crash, to its credit. But I can set my recitation to Z1000 or whatever I want. I can change all these cookies. I can change these cookies, but I'll probably be logged out of buffalo.edu. Depending on what these are, maybe I'm not logged in anyway. Maybe those aren't auth things. Let's go to let's explore a little viz.com. which is a site I've never been to, so hopefully this isn't something ridiculous. Okay, cool. Not inappropriate, I meant. So let's sign up. I'm going to have to verify my email, ain't I? I'll use this to demo this other thing. I'll demo this again in a later lecture when we're talking about it. But just since we mentioned it earlier today. If I log in. Oops. We go to the network tab. Let me log in. Login failed. Oh, did they actually send a 401 on the login failed? And if I go down to the body of this email, there's my password in plain text. Every site, like I said, I've only found one example where this wasn't the case. That password is being sent in plain text in my form data. I'm getting, this is the body of the request. This is URL encoded. We should be able to see content type here. Form URL encoded. I have a URL encoded, plain text password. Since this is an HTTPS connection, it is encrypted, which is where we get our security. But any site you go to, it's going to do the same thing. It's sending plain text passwords, but they are encrypted, so you're still looking good. And we did get a set cookie. Hey, look at this. So we got a session ID cookie, which path it's going to be sent on everything. I believe that's the default. I don't think you have to specify that. It expires April 10th at 3 p.m. GMT, and it's an HTTP only cookie. So if I go to my console, this cookie session_session ID, and do document.cookies, I don't expect to see that cookie. User visits. I wonder what happens if I can't edit it there. But we won't see it. I don't feel like looking through all that, but it's not going to be there. I'm confident it won't be there. If we go to cookies, I'm curious what happens when we jack up the user visits. What if I've been here a million times? What if it shows different content? Oh, look, you're a veteran here. That is different content, right? I didn't pay enough attention to know how different. Where'd that go? There it is. It's possible that that's just random, though. Yeah, I think that's just going to be random. Let's see what else we get. And we got a lot of cookies here. And this is common. Like when we go to our network, now that we've been to this page, they know who we are and everything. They're using a lot of cookies, and our cookie, I mean, it's a lot of cookies. So let's get back here. So let's go to all cookies. I guess we can't do that. And we also see a lot of third-party cookies here. So these are going to be same site none cookies, because they're being sent on every request. But these third-party cookies, well, that one's not even a third-party cookie. So that might be Viz tracking us when we're somewhere else. But you can see a lot of data tracking cookies. This is how you're tracked throughout the internet. This is how one company, like Google, look at how much they have their hands in here. Google can see everything you're doing effectively. I mean, you're going to see Google cookies on so many sites. And sites use things like Google Analytics. Well, Google's not doing that for free. I mean, they are, but they're adding cookies to all those requests. Look at how many Google cookies we have down here too. Facebook has their fingers in here. Twitter has their fingers in here. Pinterest, for some reason, has their fingers in here. They're all watching you and collecting data on you, mostly so they can shove ads in your face that they think you'll click on. Unfortunately, that's what a lot of top talent is doing these days, is figuring out how to show you ads. But they're giving us these tracking tokens so they can see every time that we get every time they get a request with this token, they know that that's me. Now, I'm not logged in. They don't know who I am, but they can start piecing things together. Oh, this user went to viz.com 18 times in a row, just mashing refresh. Like they can use that information for something. So if I go to Facebook, well, it's not really gonna. This isn't really gonna work for me though, because I'm not gonna log in. Facebook news. I need to get to something other than their login page. And if I can see some ads, I should start seeing ads for some anime content. I don't think I'm going to see ads because I'm blocking them. I don't have an ad blocker installed on this machine though, but oh, I'm not blocking ads. It's crazy I didn't see ads there. Let's try Google. You know, I don't know if I'm going to be able to set some up, but they did collect information. They're starting to learn about my about me. Actually, let's see if we can see the same tokens here. So Google, God, there's so many of them. Why you got so many of them, Google? Looks like these, at least one's the anid, nid, anid, at least AHW, anid, AHW. So they know that I'm the same user here. And if we look at the network tab, we should be able to see those third-party requests as well. Which, you know what, I'm not even going to try to parse through all these and find them. Can we add domain on here? Yeah, domain. Okay, I will try to find them. Google Analytics. We got a picture from Google. A library from Google. Google Analytics. Facebook events. So with Facebook, there's probably a right here. Well, that's not necessarily it. Oh, we're over time. Let me end lecture right here. So that's cookies. Yay.